Assalamualaikum and hi. We are from Group 13 will present to you about interference test. We have 5 members in this group which are Muhammad Abdul Rahim Muhammad Anwar, Muhammad Razi bin Muhammad Arif, Muhammad Rashdan bin Rosli, Muhammad Zulhafiz bin Muhammad Zu, and Muhammad Zarfan Izzuddin bin Jalil. Before we get into the topic, let us see the lesson outcomes that we should get after the presentation. The first one is define interference test and its functions. The second one, able to differentiate the cases which occur at the well. The third one, determine the porosity and permeability of the well. The fourth one, calculate the well bore pressure based on given data. The fifth one, able to match the plotted graph with the master interference graph. And the last one, comparison between pulse and interference test. That's all. My colleague will continue for the next part.
Hi, my name is Muhammad Abdurrahim, and today I'm going to present about interference testing. So let's start. Interference testing is one form of multiple well testing. So first, let me uh, explain what is multiple well testing. Multiple well testing involve larger radius of investigation. It not affected by skin. Also, skin or will affect the active well. One producer and one or more observation well. Finally, well-bore storage effects are maximized. So let's back to interference testing. As I mentioned before, it is one form of multiple well testing. These tests are used to determine whether two or more wells are in pressure communication in the same reservoir, and when communication exists, to provide estimates of vertical formation, permeability, porosity, and compressibility product. The porosity and thickness are the same everywhere in the reservoir. Permeability also the same everywhere in the reservoir in all directions. Interference is conducted by producing from or injecting into of these wells, active well, and the pressure response observed in the other well, observation well. The active well starts producing at uniform pressure at time zero, and the other pressure responds in the observation well at distance r from the active well begin after some time. So, what is the interference testing function? To improve the estimate of direction of permeability and reservoir storability. Also, we know of, if the two wells are connected or not. Also, to know the flow pattern isn't turbulence or laminar flow. And finally, to know the reservoir properties between the two wells if they are the same or not. So now, my friend, they are going to proceed to explain more about interference testing.
Yes, my name is Muhammad Razi bin Muhammad Arif. So today I would like to explain about interference testing, case 1, where the active well is producing or injecting. So here's the formula for the stabilized well pressure, which is PWS is equal to P1 hour plus M log T. This equation can only be used if this requirement is met. The equation is 0.0002637 permeability times time over porosity times viscosity times total compressibility times R square. And the R here is the distance between active well and the observation well. So if the calculated value is over 100, then we can use the equation here. So first, we need to do the semi-log graph, plot the semi-log graph by putting the PWS, the stabilized well pressure, at the y-axis and time at the x-axis. After that, we find the M and the P1 hour. The M here, you can find it at the slope of the graph, while P1 hour, you can just you can just find the pressure at time 1 hour. So after you gain the data, you can find the permeability, which is equal to 162.6 flow rate times viscosity times formation volume factor over M, the slope we gain from the graph, and H is the depth of the well. After you calculated the permeability, you can find the porosity by using the equation porosity over viscosity times total compressibility times R square exponential Pi, which is the initial pressure, minus P1 hour gained from the graph over M, also gained from the graph, minus 3.2275. After we calculated the permeability and the porosity, we can insert the data in this equation here to find whether the calculated value is over 100 or not. If it's over 100, then we can use this equation. PWS is equal to P1 hour plus M log T. So you can find PWS at any time you want. So that's how you do the interference testing in the active well, if the active well is injecting or producing. Thank you.
Assalamualaikum and hi. First of all, I would like to introduce myself. My name is Muhammad Rashdam Mirosli, ID 19462, and I would like to present my part, which is the continuation from the before, which is the case 2. So what really happened in the case 2 is when the active well is shut in after producing for time, TP. Okay, you can see from below over here, the diagram. This one is called active well and this other one is observation well. So what really happened is the active well is being shut in, means that there is no longer producing or production of the well. So different calculation and different step that need to be taken into. Okay, during the time when the well is shut in, we can calculate the wellbore pressure by the formula given below. PWS, which is the wellbore pressure, is equal to Pi, initial pressure, plus with the M, the gradient of the graph we plotted, the straight line, log times with Tp, the producing time, plus with the delta T over delta T. Delta T over here, as you can see, is the product from the T2 minus T1, or you can say T3 minus T2. By that, we also can determine porosity and permeability of the well. But first, we need to take a look of the given data, how to plot the graph based on PWS versus TP plus delta P over delta T. And then, find the suitable points and draw the straight line from the plotted graph. After that, find the gradient of the graph, the straight line M, and by that, we can calculate the permeability of the well by the formula given here, which is K is equal to 162.6 Q, the flow rate, nu, the viscosity, the formation volume factor over the gradient times with the height of the well. Porosity also can be found by the formula given here, which is the permeability as we calculate from the above. We put over here the value over the viscosity times with the total compressibility times with the radius where as times with the exponential of the in the bracket P pressure at 1 hour based on the plotted the graph we plotted minus the wellbore pressure PWS, which we can see at the plotted graph at time is equal to 0, delta time is equal to 0, and find the match point. Okay, then divide by the gradient of the graph minus log plus 1 plus 1 over what do you see time tp minus 3.2275 close bracket, and by that we can calculate the porosity permeability of the well in the case 2. So that's all for my part. I proceed with the next part.
Assalamualaikum and hi. My name is Zulhafiz and I will continue the presentation. I will present to you about how to do interference test by using log-log type curve. So, the first step of this test is we have to construct a table of delta T time and delta P pressure. A set of data for delta T will be given and we need to calculate delta P by using this formula, which is delta P equal to initial pressure minus bottom hole flowing pressure. The second step is we need to plot a graph of delta P versus delta T on a log-log graph after all the values needed is obtained. This is the example of log-log graph, but it will be much easier if you use tracing paper. Then, the third step is we need to match the graph that we plot with the log-log type master curve, which you can see here. After we get the mesh point, we will be able to obtain some properties which are PD, dimensionless pressure, delta P, T, and TD over RD square, which is dimensionless time over dimensionless radius square. And the last step is we can calculate the permeability by using this formula. K equal to 141.2 QB mu over hash PD over delta P, and porosity equal to 0.0002637 K over CT mu R square times with T over TD over RD square. Next, I will proceed to the next part, which is the development of multiple well testing. As we all know, multiple well testing consists of interference and well tests that involve more than one well. So, here is some comparison between interference and pulse test. As you can see here, interference test is a long duration rate modification in one well that creates a pressure interference in an observation well that can be analyzed for reservoir properties. The second one is this analysis technique is simple by using type curve matching. For the pulse test, it provides equivalent data by using short rate pulse. The second one is pulse test values are much less affected by boundary conditions than interference test. The third one is analysis technique is more complicated and usually requires a commuter. So, that's all from me. I will pass the presentation to my colleague Zarfan. That's all.
Hey guys, I am Zarfan, and now I would like to help you guys on how to solve the interference while testing. So here is the one of the example of the interference while testing. So let's have a look on the question. From the question, we need to determine the permeability and porosity. So here is the data given that are needed to calculate permeability and porosity. The data for times and wellbore pressure are already given here. For the first data, time is equal to 0 and wellbore pressure is equal to 0. Since we are going to plot a log versus log graph, we can ignore this data. And at the last data of wellbore pressure, it is stated as N. we cannot plot it, so we just ignore this data. Then from this 6 point of data, we just only take 4 data to be plotted. Then now we solve the equation step by step. Step 1. Plot the graph of delta P against delta T on a log-log graph. By plotting all the data given, we should get a graph that looks like this. And then we proceed to the step 2. Match the plot with the master curve. In this step, we need to adjust the plot graph to ensure that the plot lies on the curve of the master curve. Then it will look like this. Then we proceed to the step 3. Find the matching point from the plotted graph and the master curve. In this step, I pick the intersection point from the plotted graph and the master curve. In this yellow region, this is the matching point. From this matching point, we can obtain delta P, delta T, PD, and TD over RD square. So, delta P is equal to 100, PD is equal to 0.92, delta T is equal to 10, TD over RD square is equal to 0.85. Step 4. Calculate the permeability and porosity by using the formula. This is the formula for permeability. K is equal to 1 for 1.2 times flow rate times formation volume factor times viscosity over height times PD over delta P that we get from the matching point. So we just plug in the data and calculate it. So K is equal to 4.91 millidarcy. Then we move to porosity. This is the formula for porosity. Porosity is equal to 0.000267 times K over R square times CT times viscosity times T over TD over RD square. So we just plug in the data, we calculate, and then we get porosity is equal to 0.085 and we convert it to percentage, 8.5%. So that's all. I think we have already find the porosity and permeability. I hope you guys understand about how to solve the interference well testing, and thank you for watching.